what do you need to make this happen is our DE Freescan. So I think Cyrus mentioned this at the start, but we've developed our own scan generator, which controls the coils of the microscope. But we think does a few more things smart with it. And what we've done is we've enabled customized scan patterns. So typically how you scan in scanning transmission electron microscope is a raster from left to right. And this works quite well, but you actually have to account for flyback time. So the beam pauses at the start of each row for quite a while, and that causes extra damage in your sample. So you have to add extra dose when it pauses. So it does a row, pauses, does another row, pauses, does another row. And so people have come up with other types of scan patterns and ways that you could potentially scan. One is serpentine, where you go across like a snake. Another is a spiral, so that you focus on the center of the field of view at the start. And then there's another called alternating, which is also called interleaved or leapfrog, sometimes people call it. And so these are all strategies for minimizing the dose on the sample. And they're also being used for subsampling or compressive sensing. And so we have some collaborators working with that. And because Freescan is integrated into the mission control software, which is completely integrated into Celeritas, you get perfect feedback and perfect time locking between acquiring frames and the position of the beam. And that's really important. And it's also controllable either via our interface in mission control, or you can control it in a script. And so this is what the Rosalind Franklin Institute are doing in the UK. So they're using a Python script to control the microscope so that their experiment is completely repeatable. And they're acquiring 40 stem of biological specimens. And they're using these scanning techniques to minimize the beam damage, because obviously in biology, the beam damage is really important. And so all of this is integrated into our detector. So we have, this is a Hilbert curve, but you can see that we don't have artifacts, and you can scan the image whatever way you like.